All right, let's get right into it. Today, we are tackling one of the single biggest challenges in artificial intelligence, and that's this. How do we build an AI that we can actually trust? We're going to do a deep dive into the whole problem of AI hallucinations and lay out the playbook for making these systems truly reliable.
And this quote right here just cuts right to the heart of it. The real danger isn't some evil sci-fi AI overlord. Nope. It's an AI that's incredibly helpful, super fast, and at the same time, completely and utterly wrong, but with all the confidence in the world. This really sets the stage for everything we're about to talk about.
So, here's the game plan. First, we're going to really define what we mean by a confidently wrong AI. Then we'll dig into why this even happens. After we understand the problem, we'll get into the good stuff, the solutions. We're talking a three-layered defense system, the actual tools in our reliability toolbox, and the ultimate failsafe, the human safety net. And we'll wrap it all up with a really important shift in thinking, this idea of building for trust before intelligence.
Okay, let's dive into part one. Because before you can fix a problem, you have to be able to look it square in the eyes and know exactly what you're dealing with.
So here's the official term, a hallucination. And look, this isn't just about a simple mistake. The important word on this slide is confidently. The AI isn't just wrong, it presents completely made-up information as if it's a solid fact. And you can see how this becomes a massive risk when we give these AI agents the power to do things in the real world, like making financial trades or summarizing a patient's medical history.
And these things come in all shapes and sizes. You've got your basic factual errors. Einstein invented the internet. Silly, but mostly harmless. But it gets much sneakier. It can invent fake research papers to back up its claims, or it might try to use a software tool that it literally just made up. It's this wide range of errors that makes them so tricky to catch.
So that's the what. Now we've got to ask why. Why do these incredibly complex systems just make stuff up? They're not lying in the human sense, but understanding the root cause is absolutely critical if we want to build a solution that actually works.
At their core, large language models are basically just incredibly powerful prediction machines. Their main job is to figure out the next most plausible word in a sentence, not necessarily the most truthful one. So when you don't give them enough context, or the information just isn't in their training data, they do what they're designed to do. They fill in the gaps with their best guess. But the one cause to really focus on here is no grounding. The AI isn't checking its work against the source of truth. And that weakness, that's exactly what we're going to learn how to fix.
All right, so we get the problem and we know why it happens. Now let's shift gears and talk about the solution. And this isn't about finding one single magic bullet. It's about building a systematic, multi-layered defense system to make our AI agents reliable from the ground up.
And what's so brilliant about this playbook is how it breaks a massive problem down into three really manageable steps. First, you do everything you can to prevent these errors from ever happening. Then, you have to assume some will inevitably slip through, so you build systems to detect them when they do. And finally, when you catch one, you have a solid plan to mitigate the issue and correct course. These aren't choices, they're layers. For a system to be truly robust, you absolutely need all three.
Okay, so let's pop open the toolbox and see what we're working with. What are the actual practical techniques we can use to build out this three-layer defense? This is where the theory gets real. Our first line of defense is often the simplest, but don't let that fool you. It's incredibly powerful. It's called prompt engineering. It means instead of asking vague, open-ended questions, we give the AI crystal clear instructions and constraints. But the most important trick is right there at the bottom. You give the AI an escape hatch. You explicitly tell it, if you are not 100% certain, just say you don't have enough data. Do not guess. That one little instruction can slash the number of fabrications dramatically.
Now, our next prevention tool is a total game changer. It's called Retrieval Augmented Generation, or RAG for short. This directly attacks that no grounding problem we talked about earlier. Instead of asking the AI to pull an answer from its memory of its massive training data, RAG forces it to find the answer in a trusted document, right here, right now.
And here's the simple beauty of how it works. You ask a question, but before the AI ever sees it, the system first searches a trusted knowledge base, say your company's internal documents. It finds the relevant facts, and then it hands that evidence to the AI with a simple command, answer the question using only these facts. It's like giving the AI an open book test instead of a memory test. It completely changes the game by grounding its answers in reality.
So what if a hallucination slips past our prevention layers? Well, then we need to detect it. Two really popular ways to do this. First, you can just ask the AI to double-check its own work. That's self-evaluation. But even better, you can set up a second AI, a critic agent, whose entire job is to fact-check the first AI's work. It's like having an editor or a peer reviewer built right into the system.
So we've covered prevention and detection, but for the really high-stakes stuff, there is one last layer of defense. And frankly, it's the most important one of all, and it's not even technology. It's the human safety net.
This is the idea of human in the loop, and it's a simple but profound concept. We should not let AI agents run completely on their own in high-risk situations. It's about building a deliberate slowdown for the sake of safety. When the stakes are high or the AI is uncertain, its default behavior shouldn't be to guess, it should be to stop and ask a human for help. And this isn't just a vague idea. We can build concrete, hard-coded rules, tripwires, that trigger this human review. For instance, you can program the system so that if a task involves giving legal advice, or moving more than $1,000, or touching sensitive user data, it automatically pauses and waits for a human to give the final go-ahead. This is the ultimate backbone for building trust.
Okay, let's zoom out for a second. All of these tools, all of these frameworks, they're all pointing toward a really fundamental shift in how we need to think about building AI. It's a whole new philosophy.
And this just lays it out perfectly. This is the multi-layer reliability stack. You don't just pick one of these. You stack them, one on top of the other. You start with good prompts. You ground the AI with RAG. You detect errors with self-checks and critic agents. And you top it all off with that human in the loop for the final resolution. Each layer is designed to catch what the one below it might have missed.
And that really brings us to the core message here. For so long, the race in AI was just about making it smarter, more capable. But what we're all realizing now is that intelligence without reliability is actually dangerous. The new goal, the real goal, is to build AI that is trustworthy, an AI where we can trace its reasoning, and an AI whose answers are firmly, undeniably aligned with reality.
So, I'll leave you with this one question to chew on. As we keep building these incredible technologies into every corner of our lives, we have to keep asking ourselves this: are we just building for pure intelligence, or are we building for trust? Because as we've just seen, they are absolutely not the same thing.